So hello folks, this is our project H.O.D.O.R. So why H.O.D.O.R and what is H.O.D.O.R? Our project name is H.O.D.O.R. The name H.O.D.O.R has been taken from a very famous American TV series, that is Game of Thrones. So the character H.O.D.O.R tried to hold the door from the evil White Walkers, but he couldn't. So if he would be having any mobile device or any kind of interface with this program implemented, he would have been alive right now. So to make it possible, we designed H.O.D.O.R to hold the door.
So in short and sweet, I would like to call this as the mother PC. This is the Raspberry Pi 3. It is better than Raspberry Pi 2 because it has 1 GB RAM. This is the HDMI port and it has 4 USB ports here. One is the audio jack and that's the power source which is connected with the power source which gives 2 ampere of current. It has 40 pins for 40 connections and 1.2 gigahertz processor of ARM Cortex. This is a really powerful microcontroller, Bluetooth, Wi-Fi, which is really useful, and it is quite better than Pi 2 because it has Wi-Fi which is already inbuilt, and this can be used to connect the rest of the devices which has been implemented over here. So let's start with the first and the foremost feature of this home automation. This is the LDR sensor. Here it is the LDR sensor. A capacitor has been attached to it. The laser makes the connection and this completes the circuit. So if we close the door, I'll show it to you. So if we close the door, all the switch or everything will be disconnected as it completes the circuit. So I'll show it to you again. H.O.D.O.R is a website which has been created on PHP. It is running on Raspberry Pi, which is over there. A server has been made in Raspberry Pi, and a dedicated IP has been given. So we have connected over Raspberry Pi, and I will show you the functions of it. Pi camera. So if any connection is made, for example, a person comes in, so the Pi camera will take the photo and it will mail to the registered email ID. So if, for example, if a thief or any person comes into the room, he is the Pi camera takes the photo and we get the photo on the mail ID, registered email ID.
So right now we are dealing with the temperature and humidity sensor. For that we are using the cron job, whose main job is to update the data in after every 20 minutes, and it updates the data into database. For database we are right now using MySQL database connectivity, and also to retrieve the data we are using PHP. PHP then connects the data with the help PHP then connects the page with the help of Ethernet or any wireless connectivity. For this graph that is being shown on the laptop right now, we are using the Google APIs. The orange mark that you can see on the graph shows the humidity. These are the main intervals that has been taken after every 20 minutes and has been updated periodically. And also in the blue, we are able to see the temperature updation. This data has been shown for the whole one day.
So our next module is the soil moisture sensor. First, I will tell you the scope of it. The soil moisture sensor works fine in the places where there's scarcity of water and you don't have much time to look after the plant. So you just need to install the sensor, which is soil moisture sensor, and this works totally fine. I will show you how it works. This is a soil moisture sensor. Right now there's no water in this, so there will be no conductivity, which we cannot see anything right now. So we are seeing a sad plant over here because there's no water inside it. I will show you how it works. So right now we can see that after pouring the water, there's moisture inside the soil. There's moisture inside the soil, so conductance is happening and there's a happy plant. So we can even monitor it from our smartphones like this. This one has a huge scope in the market. We can do it in the less water areas like Rajasthan in India. For example, I live in Amity University, Rajasthan, and this is a very dry state. So we cannot water the plants every day as we don't have water so much. So if we install this soil moisture sensor about 10 meters or 20 meters, we will get a perfect data on how much moisture is there inside the land. So when we will fix a threshold limit for that, and if the water moisture comes below the threshold limit, our sprinklers will water the plants, and when they are above the limit, the sprinklers will close.
So as we can see right now, I'm applying some smoke in this sensor. So sensor. So here in smartphone we can see that the sensor has already taken the value. That is, we are not safe right now and we have to move out immediately. Gas sensor technical name is actually NQ135. Also, it has three pins: VCC, ground, and data pin. So VCC is responsible for applying the voltage. Data pin is responsible for taking the data. Also, if you look at the gas sensor right now, there is no smoke right here. So it is sending a zero reading to the system. The moment it gets any kind of smoke or any kind of gas, it sends one to, that is a true boolean value to the system. So in future we can really use this gas sensor module, like for example in big laboratories and factories where a lot of work is done on chemicals and gases. There has been many precautions that has been taken recently because of the man-made disaster. So instead of taking any kind of precautions that are really costly, we can actually apply this module and get our task done simply. That's it.
So this is our next module. This is the ultrasonic sensor. The main working principle of this is first the echo is sent from here. It goes from here to there. And trigger comes from there to here. The main principle behind this is the time is calculated, and by the time we get the distance. So by that distance we calculate a threshold, we fix a threshold, and if the threshold breaks, the alarm triggers. I'll show you that. So here you can see that we broke the system. We opened the window, so the alarm triggered, and according to the programmed system, the lights started to shut down and started to switch on and off. And the best thing about this is we will get a notification. The Pi camera will take a photo of it, and we will get a notification in the mobile here. This is the notification, so we can easily capture the thief or any person who is breaking the system who comes into the room. Tell you about the future scope of this home automation and this ultrasonic sensor. If you're trying to buy a new house and if you're trying to make it into a smart home, then this ultrasonic sensor is one of the major important feature you should implement in your house. If a thief or any person tries to come through the window, then it will trigger an alarm. It will send you a mail. It will send you a mail and a notification, and you can further add a feature that you will contact the police automatically. So this is one of the most important feature.
We can see right here the ultrasonic sensor has been connected with among the two resistors also here if we have a look, we are connected with those sensor along with the two resistors, and just over here we are connected with all the sensors. Also we can see that ultrasonic sensor is supplying 5 volts of voltage, and rest of the remaining sensors like temperature sensor, soil sensor, gas sensor, switch, and also door status switch is applying with 3.3 volts. So the main purpose of our project is to handle the AC devices. In order to handle the AC devices, we need 230 volts of voltage. So what we did here, what is that we used 4 switches of relay switch, and we connected the wires to Raspberry Pi. 4 switches of relay switch, and we are also using the 4 GPIO pins from Raspberry Pi. You can see that we have connected the 12 volts supply with relay switch, and that relay switch ground has been shortened with the Pi. Also, we can demonstrate with relay switch that has been connected with the AC supply just right here. So what we have done here is that we have created a hotspot, and our hotspot is being connected to Raspberry Pi right now. We are having an interaction with Raspberry Pi. So we can see on the web page we are having some few buttons, that is home, automation, about, and of course team. So starting with the main theme of our project, that is automation. Automation has first categories are living room, then temperature sensor, then plant, or you can say a soil sensor. Then we have a gas sensor, a security purpose sensor type of thing, and then we are having a last but not the least category, that is capture. So as we can see, we have used the basic bootstrap file along with some basic CSS, and of course the HTML. So here's the table which has been created on PHP for the dynamic purpose. So here is our plant sensor, or you can say soil sensor. We have used a basic image of plant which tells that no water is required, and the gas sensor tells us that if we are having any safety purposes, we have capture that is being controlled by a Raspberry Pi camera, and it takes a photo right now, just having a demo. So here's the demo of Raspberry Pi camera. We can see here's my friend Apoorv standing over there with his very weird look. So we can now stop the camera. So this is our about page that tells what is our project all about. It tells about H.O.D.O.R, how it all started. We are using the elements here and the functions, the specifications, all of the whole theory that we have used is simply over here. So here's a team that is containing 3 members. First is Smit, then Apoorv Neeraj Verma, and last that's me, that Prateek Gogia. Prateek and Smith are responsible for UI and a partial hardware, and Apoorv is mainly responsible for all the hardware stuff, all the connections, all the Raspberry Pi interaction and all. So yeah, that's our team.